And I'm Peter.
And this is our 3 resistors video.
Good luck.
Hi, we're going to walk you through our very simple resistor today. We're going to start you off with Ohm's law, which is V equals IR. So now your current starts with a power supply of 5 volts. It's going to move through the circuit this way, coming up to the first resistor at 100 ohms, the second resistor with the same amount of ohms, 100, and the third resistor with 100 ohms as well. When you total all these together, you just have to add them, and we get a total of 300 ohms. So plugging that through the equation, we see that our current is going to be at 17 milliamps throughout the entire circuit.
So in this shot, you see we have worked out the math for you. It's just simple Ohm's law, V equals IR. We have 5 volts equals your current times your total resistors, which is 300 ohms. So once you break that down, you end up with 0.016 amps, which is your current throughout the entire circuit. Another circuit for you here that we've drawn up in LT Spice. So you can see we've got 2 resistors in series and 1 in parallel. The current that goes throughout it will be split between the 2 resistors at 25 milliamps, and then the other resistor R3 will have the 50 milliamps.
For this next circuit, we have all 3 resistors running in parallel. From the 5-volt power supply, we headed clockwise until we hit the 3 parallel resistors. To find the resistance in that part of the circuit, we first multiplied each of the resistors together, then we divided that by the sum of the 3, which came out to be 3,333.3 ohms. From there, we used V equals IR to find that the current in the circuit was 1.5 milliamps. But wait, we are not done there. We then needed to divide that number 3 ways to find out the current through each of the resistors. That came out to be 0.5 milliamps. This circuit consists of 2 resistors in parallel and 1 standalone. To find the resistance, we multiplied the circuits in parallel together, then divided by the sum of the 2, which came out to 50 ohms. We then added that to the third resistor to make it 150 ohms. After that, we used V equals IR to find that 33.3 milliamps of the current ran through the circuit, with that being split evenly between the 2 in parallel when it comes to it.
This is a shot of the power supply. You can see that we've got the voltage set to 5 volts limited, and you can see on our DMM, the digital multimeter, that it is actually 5 volts. So this is what a breadboard looks like. We just want to show you an image so you can get an idea of how the connections are made. So when we show you how we actually set up our resistors on the breadboard, you can kind of get an idea of where the connections lie in the back and how we are actually connecting those wires and resistors. We picked the easiest circuit for our first go at it. You can see the way that we've actually put the circuit on the breadboard is the 3 resistors right below each other. Once our circuit is hooked up to the DMM, you can see that it has 5 volts running through the entire circuit. The first 2 resistors will have 3.34 volts running through them, and just the first resistor will have 1.67 volts. We broke the circuit at the second and third resistor, and when we hooked up the DMM, you can see that it has 16 milliamps running through it. And as you can see, when we break the resistors at the other spots, that each one of them also has about 16 milliamps running through it.